Today we'll be going over this laser rotary roller. The name is so funky that even I don't know how to pronounce it. And most likely this is rebatch of a rebatch of a rebatch, meaning they're all the same, just different names. Now the reason why you're seeing it as inexpensive is because this whole thing comes unassembled, meaning that you have to assemble everything, including the motor, the rollers, the screws, everything. So in this video I'm going to show you how to assemble it because the instructions were very basic. It was just a piece of paper. One of the reasons why I bought this roller is because the official Comgrow rotary roller is too small. Meaning if you're trying to do anything greater than say 80 millimeter, then it would not work. So here's a tumbler that I bought from Walmart. It's huge. It's about 3.75 inches in diameter and 12 inches long. I tried this on the Comgrow rotary roller, but that didn't work because, as I mentioned before, the official Comgrow roller is way too small. So let's first install the frame. Notice the arrow is going towards the left hand side, and when you flip it over, the arrow is going to the same left hand side. On the top, make sure that the two screws holes are aligned with each other, they're facing each other. So go ahead and first try to mount the two acrylic pieces as seen here. One of them is mounted vertically, meanwhile the other one is mounted horizontally. The first acrylic mount will stay in place, meanwhile the second acrylic mount will move as needed. Alright, they give you bearings as well, so make sure that you squeeze the bearings in to the acrylic mounts. It only goes in one way, and this is the way that you mount it. Next up, we're going to mount the acrylic on the opposite side to hold the roller into position. So go ahead and get another bearing in and get into position of the acrylic, and then tighten it down with the screw. Next up, we're going to do the same thing with the second roller. So go ahead and insert the bearings in. Place the acrylic mounts in to hold the roller in position, and then finally screw it down in place. Now that we're done with holding the rollers into place, let's go ahead and mount the motor. The motor uses 4 little screws, and it aligns perfectly with the 4 holes on the plates. Now that you're done with the rollers and the motor, let's go ahead and mount the teeth. On the shaft of the motor, you can see that there's a slight cut. So go ahead and insert the teeth in and then tighten the screws down into that cut. They're nice enough to include a hex screwdriver, so go ahead and use that to tighten it down. Next up, we're going to do the same thing to the rollers. On the rollers, I didn't notice there's any cut, so hopefully this teeth doesn't slip and slide. I don't know why I accidentally forgot to make a video of it, but the last 2 screws you'll be using it for here and here. You'll also be using the bearings that's left to make it as well. These 2 screws right here will act as a belt tensioner. So once you strap the belt on, from here to here, loop down to here, back up to this roller, and then back down here. This last screw right here can be adjusted to go up or down, and try your best to push it all the way down to tighten the belts. If all is done correctly, then your belt should move smoothly. So this is what my final setup looks like. You can see that this tumbler is huge and this roller itself is also big. So that's why I'm propping the whole laser module onto cans. One other thing you should note is that the cable provided is not compatible with the Y-axis of the Z1. So I'm using the Y-axis of the Z1 itself and just connect it straight to the motor. And as you can see, I'm using a string, which is actually teeth floss by the way, to hold onto that Y-axis core. That way, when I don't need to use the rotary roller, I can plug the Y-axis back into the same motor. Here's a closer look at what that Y connection looked like on the roller. It's plugged directly into the new motor, Meanwhile, you can see the piece of floss right here that's attached. This is the second Y motor. Here you can see the wire is disconnected and stay disconnected. Don't try to connect it to anything else. As mentioned earlier, the Comgrow is for the smaller diameter objects, and here you can understand why. The Comgrow is much smaller compared to this FAHKNS roller. When you connect the Comgrow to the Lightburn or to Laser Gerber, you definitely have to change the stepper parameter because this motor is much smaller. Whereas if you connect this motor to Lightburn, you don't have to change any parameters because it's exactly the same motor as the Comgrow Z1. Here's another angle, and from this angle, you can see how much bigger the FAHKNS roller is. In this position, I'm doing it for the 3.75 inch diameter, and you can change the roller position to something even bigger by moving it to the left or to the right to make it smaller. I'm definitely not going to make it smaller. If I'm doing anything smaller, I'm just going to use my Comgrow. Let's jump into Lightburn and see what it looks like. Click on Devices, click on your laser, click on Next. It's connected serial, so click on Next, Next, and disable Auto Home. You definitely don't want the roller to be spinning when it's connected to Lightburn. Next up, go to Laser Tools, go down to Rotary Setup, and enable Rotary. The diameter is 20.2 millimeter, therefore it will automatically calculate the circumference, which is 63.4 millimeter per rotation. You can leave everything else blank. Now let's do a material test to see which setting is best for this tumbler. My minimum would be 1500 millimeter per minute, max is 2000. Power would be between 10 and 50%. Right now it's in fill. So I'm going to change that to line because I don't need fill for now. I'm just going to use line. So click on Edit Material. And in the mode, click on Line. Click on OK. You're done. Click on Preview to see how long it will take. In this case, it's about 3 minutes. Position your tumbler and then click on Frame to make sure that everything is in position. When you're all set, click on Start. After 3 minutes and 15 seconds, this is what the result should look like. Here you can see the speed is too fast because it was shifting, you see it? On the top, the boxes are more towards the left. Meanwhile, on the bottom, it's more towards the right. So I have to play around with the material test to make sure that the speed is lower and maybe the power be higher. Alright, hopefully you found this video helpful. I really appreciate you guys subscribing to my channel, and thanks for watching.